Right. Should we go for
Great.
it then? If you,
Yeah, yeah.
oops, somebody else.
There's somebody
Yeah.
there now. Yeah,
I'll
great.
let you carry
Yeah,
on
we'll start.
admitting,
Yes.
yeah.
Good afternoon, everyone, and you're all very welcome to this CIBSE Healthcare Group webinar, New Thinking for Medical Locations and Surgical Robots. My name is Edith Blenner-Hassett. I'm the current secretary of the CIBSE Healthcare Committee, and we're delighted to welcome Ian Shell, who wrote Megan in 2002 and is a medical device consultant and an independent advisor on medical safety. And I'll leave it to Ian to say a little bit more about himself as he goes through his presentation. In terms of housekeeping, if everybody could just make sure you keep your microphones off. We're not able to control them centrally at the moment, and keep your cameras off. And if you have questions, put them in the Q&A and we'll pick them up at the end of Ian's talk. So thank you very much, Ian. Just hand it over to you, and I'll mute my microphone as well, and I'll turn off my cameras for now.
Thanks very much, Edith. I'll just start up my presentation and then could somebody confirm, would Edith confirm that she
Yes,
can see? Thank you,
yes, all
Edith.
looks well, thank you.
Good. Right. Okay. Thank you very much. And excuse me, I might have to take the occasional sip of water. I'm just coming out of a bit of a virus, so hopefully my voice holds out. Okay, I'm Ian Chell, and today I'm going to be talking about medical locations, which, as you know, is the wiring in the medical rooms, medical surgical robot equipment, and a new circuit concept which I feel can succeed medical IT circuits. Now, my other ulterior aim for today is to hopefully gain the trust of somebody to trial this circuit in the UK or even the Republic of Ireland or even abroad. NHS Scotland are in support of this, and we are now exploring how the new medical TNS circuit could be trialed. Okay, I'll explain it a bit more later. And I hope this presentation demonstrates it is the way forward. Okay. So just to explain my background, I had 22 years with Siemens Medical, starting as an apprentice. I did power control, and I was an X-ray engineer for many years. After I'd done my masters, I moved to MHRA as a medical device specialist, and it was me that led and produced the first version of Megan. But just as that was published, I was promoted into the main department of health as an actual radiation policy lead. Sorry, can I interrupt? Somebody's got the microphone on. I've got crosstalk. I'd be grateful if you could turn it off. Thank you. Um, yeah, and so I was a policy lead for radiations in the Department of Health until I took voluntary exit in 2017, and I run my own training venture, medical locations. I'm now quite retired as such, but I still do that training if asked. I don't actively seek such training. I'm still an independent advisor to government on medical device electrical safety. So my brain's still quite active in this area. I feel I've got a lot of experience and the pedigree to talk about this area. And I've been supporting the police this year with two cases. One was a recent death inquest, which was only 2 weeks ago, and there will be implications for medical locations. And I was the expert witness in that investigation and the consequential death inquest. And there's going to be a Reg 28 notice, and I will circulate that to CIBSE. I'll talk about more about that in a bit. Okay. Basically, with medical locations, that's my website. But those of you who do designing, you will find on my final testing page, I've uploaded protective and supplementary protective earth diagrams because I feel there are issues with current guidance. Because you can argue that it's correct, but electricians do misunderstand it. So I produce much more simple versions. If you've got any questions, please don't hesitate to contact me. So moving on, with medical locations, I've got a lot of experience with teaching about how to do a medical location, and I can say confidently that the most important aspect of a medical location is to follow a strict governance policy to design a medical location. And as far as I'm concerned and how I train people, this means clinical staff on the first day completing a template to state what devices are being used in that location, where in the room, how many, and the clinical application. And as I say, it's on day one, and you should not move forward with the design until you have all the information on the medical devices being used. I have so many examples where this wasn't done, and guess what? It wasn't wired correctly. Okay. And from this completed template by clinical staff, the designers can group the location, put the supplies in the right place, and establish if a UPS is required and how long you need that, and so on. Quite often, again, the time calculations are not done for UPS properly. And disappointingly, the feedback I regularly get after I've trained maybe a large trust or a large organization, that the basic issue is that there was a general lack of interest by the leaders with this governance process. And I recently had feedback in so much as they've probably gone back to their silos again instead of working together. Okay, so it's a big problem in my view. Now, it's crucial, as you all know, that the installation meets the latest 7671 A2 and A3 amendments, especially for the new measurement and wiring schedule requirements. But you'd be shocked to know that a lot of places I go to, this isn't done still. I go in a new room, I look at it, and there's no wiring schedule, and okay, I can't quote figures on how many fail, but it's still commonplace. And any rooms such as radiology need to have the room compliance checked, especially earthing and the supplementary equipotential bonding, to make sure it complies with Amendment 2 and Amendment 3. Now, in terms of designing, I'm not going to dwell too long on medical locations. I haven't got the time today, but I mentioned about this death inquest. There is now a new foreseeable risk, okay? And it's all to do with emergency power offs, a contactor switch gear, and remote on offs, okay? Now, what will happen is that all EPOs and contactor switchgear will need to be replaced with new radiology interventional equipment, and they all will have to be checked to see if that has been done. All on-off push buttons should have a lamp in them from now on. This is because it enables the radiographer to identify if the contactor has dropped or not. In this incident, there was no remote on off, and the lights weren't working in the contactor box as well. So I won't go into that too much, but you've got to ensure the remote, if it's needed, also has lamps installed with clear on-off buttons at the right height. Okay. Another issue for designing, which I've seen, and I think I have to be straight, managed sites are an issue because of the contractual issues, saving money. You must change all the socket outlets in a group 2. If you're changing the radiation, I beg your pardon, the X-ray equipment, simply change all the switchgear and the socket outlets. Because I see worn socket outlets with poor earth connections, and for the medical device, that is important in a group 2. Okay, that's just a quick brief overview. Again, with the UK issues, estates have the responsibility of wiring in the hospital, but not what devices are used in the location. As I said before, clinical staff need to respond to a day one questionnaire, how many devices, where they are used, and how. Okay. Installing a scanner, for example, Somebody should add up how many devices will be used in that scanner room at one time. I trained a hospital last year, and as part of that training, I looked at a PET CT scanner to do a mock compliance test, and it failed. I went through the process of how they had worked out what devices in the room were to be used, and they didn't do that. And the big omission was that no sockets or earth studs were fitted on the head end of the scanner, because nobody had worked out where all the devices were going and how many will be used. Okay, it still goes on. That was last year. I think electricians now need to be formally trained and accredited, just like in homes. Okay, there is no regulatory system for hospital wiring like with homes. In my view, it only needs an extra training of around 5 hours, so it's not a burden. I'm not after the work. This is me as an experienced person in this area passing on and saying there is a gap. One of these gaps is that there needs to be some form of regulatory control and with the governance. But that's for now. Another big one is that electricians are not doing. They certainly are not reading the A2 Amendment 2 requirements of 7671. Okay. And it's quite, I've got some examples in a second, but again, I can only repeat what is going on, and something needs to be done about it. These are two examples from hospitals, recent. On the right hand side is a contactor box for an x-ray room. Excuse me. This was installed in 2022, and as you can see from there, it's got the non-harmonized colors, which means that that's the original wiring. Even worse, the x-ray equipment was upgraded from 30 kilowatt to 50 kilowatt. It is obvious that the hospital electrical safety group did not consult any radiology staff, and what it meant was that the new 50 kilowatt generator cannot undertake the examinations it should be able to undertake because the cables are too thin. And this has many legal implications for the hospital. It's a big risk to the business, and it's a risk to patients, because patients are being exposed to x-rays, and then that clinical image is no use because it's not powerful enough to produce the right image. On the left is an EEB that was installed last year, and it certainly does not comply with Amendment 2. Basically, the electrician had not read Amendment 2. Also, it's not neat. I like to see the bars divided into medical device, the clean earth, and the extraneous connections. And it needs to be neat so you can walk in and you know what's what. Again, it's something that needs to be addressed. So, excuse me. Pardon me. I just have a drink. Sorry. Medical TNS is a new concept that I feel can replace medical IT. I was recently asked to draft guidance on medical surgical robot equipment. That I feel is the best term for medical surgical robots. That's based on the directive definition for medical radiological equipment. So I think there's some parallels there, which is a good approach, I feel. So the solutions for this were interesting, but it highlighted three main points that the hospital electrical safety group need to review when you're installing a medical surgical robot. You have to establish the total load of the new MSRE, and also you must also add up all of the other medical devices that will be used at the same time. And the reason for this is that the basic Da Vinci robots has got a 3.5 kVA load requirement. And if you start buying electrosurgery options, it can get up to 50% of the IPS load capacity. So if you've got medical devices that add up to about 4 kVA, you're right close to the load of the IPS. So that's the first job. And I don't think people are doing that. Secondly, what a lot of hospitals have been missing is that you have to establish if one module requires a time delay miniature circuit breaker or RCBO. And it's difficult to spot this because I know in the intuitive manual, which is the Da Vinci device, it's only highlighted by an asterisk and then a footnote, and everybody has been missing it. This brings problems for supplying the new robot surgical arm, okay? And finally, you also have to calculate the UPS on time because you've got a sudden increase in load. If you're retrofitting this in a theatre, then this extra load decreases the UPS time significantly. So again, you have to calculate the UPS if you're fitting one of these. So I'm not going into medical TNS yet. I just wanted to explain first what are the issues with medical surgical robot equipment. Okay, so we're part of that now. I'm now moving on to the technical background of moving towards explaining medical TNS. Okay, so this is really important to understand this because people are mixing up earth leakage and patient leakage current. Sorry. Now, estates are responsible for earth leakage on the circuit. Clinical engineering are responsible for the earth leakage on the medical device from the plug onwards and patient leakage current. Okay, and it's important for today that you grasp the figures. Now, I'll be quick on this, but just to explain, patient leakage current is that from the applied part, it's AC, and it only can be AC because it's across a insulation. And so what we're looking at is a kind of leakage current that's up to 200 hertz, which is the issue, and it's in microamps. Okay, this is the world of clinical engineering, and it's their job to monitor and understand this, but I need to differentiate it from earth leakage. And when clinical engineering are measuring this, they use a low pass filter to remove the frequencies above 750, so there's no RF. And the reason they do this is because the heart is susceptible to AC currents around the 50 hertz mark or about that. Okay, so that's the risk. If we had DC mains, we wouldn't have such a problem. And this risk of patient leakage current goes up significantly when they're sticking things into the human body, i.e. breaking the skin, because the touch current that you're aware of is limited by the skin, which is 1 kiloohm. But when you start connecting to the vascular system, you remove that 1 kiloohm circuit. So all the values change. And that's when microamps become a concern. Okay. So for all of this, there is the IEC 60601 build guidance standard and is the key focus for limiting this current. So there's no longer a need for isolated main supply circuits. Okay. Now you're thinking, oh, right, well, what about limiting in this? Well, quite simply, if a device needs an isolated supply, the device manufacturer fits it to the device. Okay, so that is where the problem of isolated supplies has shifted to. So it's no longer a need to do this with the mains circuits. Now, secondly, in terms of patient leakage currents, BS 7671 supports this risk with supplementary equipotential bonding in group 2 locations. Okay, I call it the clean earth because it minimises EMI and patient leakage currents. I choose my words carefully with its job. Now, 7671 mentions EMD, but what it's actually doing is minimizing any interference. Okay, so that's its job, and it's in support of the above design guidance. So I want to walk you quickly through IPS history. In the 80s, when IPS was first introduced, you had no medical device regulations. We had an early version of 60601, and it wasn't always adhered to. And you could research and build new medical devices without any formal controls. And you could do this right up to maybe 5-6 years ago. Okay. No accredited approved test facilities to test devices. Material technology meant that device applied parts were conducted in metals. And for example, power injectors were made of metal then. I used to work on power injectors in the 80s, and the tests were very, very hazardous. And the use of such devices meant that you had to do many tests. Could somebody turn the microphone off, please? Thank you. And power injector plungers, as I say, were made of metal, so it was a big risk. Also in the 80s, you didn't have RCBOs. They may have been invented, I don't know, but they certainly weren't in use. And 7671 was not aligned with 60601. Moving to 2005, another crucial value to be noted is that in 2005, the earth leakage value for medical devices increased 10 times to 5 milliamps and 10 milliamps with a single fault condition. And IPS remained at the old value of half a milliamp. Okay, so please remember that. Moving forward to this year, we now have a comprehensive medical device regulatory framework. The 60601 series is comprehensive and has essential requirements for general design. And 7671 now references 60601, and it's all getting better. But even more importantly, we have accredited test facilities, and they have to independently test devices before marketing. And the same now applies because MHRA require research devices to be approaching compliance depending on the risks without going into it. So you cannot just build something and research it now. You have to formally apply by law to MHRA. So compared to 10 years ago, something big has changed. Okay, so devices are now extremely safe, including research ones. And also we have modern materials, which mean applied parts are no longer conductive. For example, a power injector's now got really impressive mechanically strong plastic. We have RCBOs, which can protect individual power circuits. And we also, in theatres everywhere, we have significantly more class 2 devices, no protective earth. And supplementary bonding is much better now. We have the radial system to support the requirements of the 60601 single fault condition to reduce EMI and to contribute to minimizing patient leakage. Okay, now I won't go into the technical side of that too much in terms of patient leakage, but I call it the backward patient leakage from, so if you had some voltage on the protective earth and it was connected to the patient somehow, then that would leak back through the medical device. So it's the only real leakage we should get is from the device through to earth, and that is regulated by or controlled by the device and clinical engineering. Okay, a lot to take in, but these are crucial points. Okay, so also I've been building up my case to show that medical TNS has a way forward, I realised that I needed to build evidence that the number of earth leakage faults with devices has also changed significantly. My gut feeling was that there were no real issues with earth leakage faults anymore. So, as well as asking hospitals, I went to a national group, which is the heads of all biomedical engineering departments. And their group has come back to me, and I quote, generally, everyone agrees earth leakage faults are rare, and visual inspections find many more issues than electrical safety testing. And I also asked about individual hospitals if they did this. I actually found out that some didn't record this, only patient leakage, but the staff could not recall any earth leakage failures, even though they were testing them. It's just that it's not been recorded. Okay, so that does need to improve, I think. Some sites had no devices that had suffered earth leakage failures. So there you go. That's the evidence. So the initial evidential conclusion that in 2025, that even now this issue appears to be significantly better than in the last century. That's how long IPS has been about. And it's maybe even better than 10 years ago. So personally, I'm convinced earth leakage failures are no longer an issue. They're a minor risk, and the only risk comes from old medical devices. Okay. So moving on, I want to explain now how I teach the risks in medical locations. Okay. So risk number one that you have to mitigate is EMI and patient leakage currents. And that's resolved with the supplementary equipotential bonding clean earth system, which is radial in a group 2. So hopefully you all understand that. And if that's not done properly, then you're not minimizing the risks. This is why the IT guidance needs to be followed explicitly. The risk of mains failure is resolved with UPS. The risk of discontinuity is currently resolved with medical IPS and IT circuits. Okay. Now, I'm not going to talk about it today because it's too much, but I also feel that the other risk is to support the IEC 60601 single fault condition, which is just a combination of the above, but not for now. So that's three big risks that we have to deal with in a medical location. So the purpose of medical IT circuits is to prevent one faulty device taking out the whole circuit. Okay. Now, some of you may think, is it really? It is to minimize the risk of final circuit discontinuity. And guess what? In Guidance Note 7, it does actually say that. If you read it in detail, that's what it does. It just stops one device disconnecting the loss of supply from all other connected medical equipment. Okay. Now, secondly, it states that it is to limit leakage currents. And this is what I'm challenging based on my arguments just from that earlier slide. And this is because device safety and design is now resolved with the IEC 60601. Plus, in 2005, that device earth leakage value was increased to 5 MA in normal condition and 10 with a single fault. So, Guidance Note 7 states it's 0.5 milliamp. And this was to match the 60601 value before 2005. But we know 2025. Therefore, in my view, we only need to look at the discontinuity aims, which is to prevent the loss of supply of all connected medical equipment when a single fault occurs on a single item. So, going back to the medical surgical robot equipment, the easiest solution to supply the vision cart on the intuitive medical surgical robot equipment, which I call the MSRE, was a time delay overcurrent protection device is to fit two new radial single GAN socket outlets protected by RCBOs supplied by the UPS. Okay, so if it's a retrofit, this means fitting 4 cables, two for live, two for neutral, and the RCBOs, the two new RCBOs can be fitted in the IPS rack. So that's 2 sockets, and I'll show you a picture in a minute. These are it, and you label them vision cart only. And the reason you have two is because if the RCBO goes on one, you can plug it in the other. There's a neon on that to show whether it's live or not. That's easy to understand by the operator. And hopefully, if it goes out on the second one, they don't plug it into anything else, because that means there's a proper earth fault on that medical device. Okay. And if you're retrofitting, you can easily find a clean earth from a nearby supplementary equipotential bonding connection point from nearby IT sockets, but you've got to make sure it's low enough because it's a time delay trip. And the other two modules, because the MSRE comes with 3 parts, and the other two can simply plug into any existing medical IT socket outlets. So that means the load of the robot arm and the patient cart are much less than the vision cart. Okay, so that doesn't really affect the medical IT too much, but obviously you've got to look at the UPS. So when you use medical TNS for the vision cart, the IPS load requirement comes down to 20% max, which is 2 times 4 amp loads. Okay. So this is the graphic solution that is suggested for retrofitting of a medical surgical robot. Okay. So on the left, you've got your medical IPS, which is 12 sockets. And this is in theatres. So you've got 2 IPS transformers, which gives a total of 24 sockets roughly. But then in addition, from the UPS, you fit 2 new single gang sockets, and it was suggested by other people that red's the best solution, and to label the device, and also to put a bigger notice around the sockets. For example, this all needs further discussion. This is my initial suggestions. And so you've got 2 new sockets for the vision cart. Okay. So this then led to, that's the bespoke sockets that Wandsworth can supply. They did me a great favour by making these prototypes. I can only suggest that you go to them. Now, if you notice, the supplementary earthing and extraneous are separate because it's on spacers. So it's the supplementary equipotential bonding protective earth is wired exactly the same as medical IT sockets. So all of this led to the concept for medical TNS. Okay. So this is the suggestion for medical TNS. So you have your UPS and then a much bigger medical TNS distribution board, which probably can take up to about 40 RCBOs. So that means you have a possibility of 40 single gang sockets, each protected by an RCBO. But you can, if you've got medical surgical robot equipment in the location, you can fit 2 time delay RCBOs and supply separate sockets. But if you notice, any medical TNS only goes in the patient zone. Okay. And then you have your normal TNS distribution board for sockets outside of the patient zone, and they would be white, whereas the medical TNS are red. This is because the advice that somebody suggested, because currently sockets that are supplied by the UPS have red switches on them. So this just takes that further. Obviously, I'm not a standards guy. I'm not employed by anybody anymore, but these are strong suggestions that need to be considered. Now, if you notice, all of these are wired exactly the same as medical IT sockets. They each have their own radial earth, supplementary earthing, going back to the EBB. If they're mounted on metal, then they are isolated from the metal conductive parts. So why can it replace medical IT? Well, as I've said before, medical IT circuits with an IPS is to prevent the risk of discontinuity caused by any device on the same circuit, not on any other circuit. So discontinuity is the electrical term used to describe an RCD or thermal trip activating and removing power from a circuit, or the same with an RCD. And it's evidence from IT Guidance Note 7. Therefore, it clearly has the same function as an RCB, except it alarms and not trips. And remember, it was introduced before RCBO circuits. And IPS's alarm at the pre-2005 device limit, half an MA. And now medical devices are only failed if the leakage value is above 5 MA in normal condition, or 10 MA with a single fault on. So you've got to understand that the isolated circuit does not limit patient leakage, because that's in microamps, okay? It's not in the milliamp range. So how is an isolated power supply protecting the patient? Yes, it does provide some form of current limiting, but it doesn't tally with anything now. And as I mentioned before, you have a complete different level of medical device safety, and we have our CBOs, okay? And we also have the supplementary equipotential bonding to support these design features of a medical device. So the isolation is only the technical means of being able to monitor the whole circuit from one transient spike when one device's insulation starts to fail. So RCBOs can individually protect each device by having one RCBO per single gang socket. So what are medical TNS pros? Well, this is the good one. It significantly costs less than the medical IT circuit. A rough estimate would be about £10,000 per medical IT 10 kVA circuit. Okay. Large loads. Sorry, somebody keeps. Yeah. People keep coming into the room and hiding my text. So large loads are easily tackled by MTNS by individually protected RCBO circuits. The risk from one faulty device is limited to its own circuit, okay? Exactly the same as with medical IT, except you don't get the alarm. But remember that we're not getting the faults these days, that patient limit current is limited by the device, not the circuits. So also, compared to medical IT, medical TNS has a simple red LED in the socket, which is much simpler than expensive monitors, which require training. There is no training required for a simple lamp on a socket. Everybody will understand it compared to the alarm in a Group 2 environment, okay? If staff plug the medical equipment, if you get a circuit trip, and staff plug the medical equipment into another socket and it trips, it shows there's a fault and it should be removed from the service, okay? And there should be enough socket outlets to be able to cope with a faulty device being plugged into more than one socket. And if they do it more than twice, okay, if it goes off the third time, hopefully by the third time, that will then tell them, okay, yeah, there is a fault. Let's not use this anymore. If it was a transient fault and they plug it into another socket, end of problem. And estates can come back and reset that one circuit. Now, MT&S can be installed around the patient zone. They could even be outside of that patient zone on a nearby wall. And if any other equipment is plugged into it, it's no big issue in terms of load, except if there was a power failure, that device is then, or that non-medical device is then consuming load during the actual power failure. But it's not such of a risk as before with medical IT. The other advantage is that medical surgical robot equipment, which has a high load, can easily be added in the future to, say, a theatre that's already got medical TNS in. Quite simply, you just swap out two of the RCBOs for time delay. So again, an easy upgrade if you add a robot. So as I said before, the Intuitive requires a type K RCBO, but they need to be specifically engraved accordingly with adjacent warning signs, okay? As I said before, the robot can be installed using another couple of MT&S circuits if retrofitting with IPS in place already. Now, also in terms of saving money, you do not need to pay for servicing of IPS controls like you do now. MT&S, it's just an RCBO, so it puts it into simple land as far as I'm concerned. MT&S is also easily understood by electricians and electrical designers. Now, if you're thinking, well, that's a lot of RCBOs, I know Starkstrom sell an MCB trip monitoring module and a remote alarm. And I'm sure something like this could be easily expanded into an alarm app for estates officers or senior clinical engineers. Well, that's for another day. So what do we need to watch with medical TNS? All right. So you need to look at the supplementary equipotential bonding values. That's up to designers. And I was alerted to this that it may need to be under 0.1. It depends on the circuitry, but watch out for time delay earthing requirements, okay? So it may be argued that medical devices may have an intermittent earth fault, but fitting MT&S with an RCBO means that the transient device will trip and they can plug it into another socket, and if that trips, they stop using it. It's that simple. But the one risk I've identified with this is that it can only be used with modern medical devices that are tested against the latest medical device standards and are hopefully less than 10 years old. So this is just a warning shot that I've done with my risk assessment. I feel that is the only risk. But in my view, why is anybody using old medical devices that are a risk? They shouldn't be used now. One possible perceived con is that one medical device may suffer a transient trip and take the radial RCBO out, but it's important to explain no other medical equipment is affected. The other con is that there are numerous live and neutral conductors for many radial sockets, but this obviously means highly populated distribution units to accommodate numerous RCBOs, but it's quite easy, in my view, to fit sub distribution units nearer to pendant arms and things like that. So I don't know the precise answer to this yet, but I think this is a really easy solution, which electricians can easily solve. And the main point being is that you need easy access to reset the RCBOs, okay? So that is a design consideration. The other point we need to watch is how do we mark each socket? I'm on about the ones that are not for the vision cards. This is the standard medical TNS socket. I feel I feel the body needs to be red because it's coming direct from the UPS, but I think it needs to be distinguished from normal TNS sockets by perhaps having MTNS or medical TNS on the socket. But again, I that's beyond me, and people in certain places need to decide that. So I said right at the beginning, I'm hoping to persuade people to come on board. I'm trying to behave as a leader and encourage people to realize that this issue needs to be seriously considered, but it needs to be trialed. I'm very confident that any trial will be successful, but it needs peer agreement. I found out that the best way forward I found out the best way to take this all forward is that I tried to discuss publishing a peer-reviewed paper, and the outcome of that meeting was it's better off that we trial it first to prove that all the theory works okay, and it needs top-down support to trial it to prove that the theory is correct and identify any issues, which I'm confident there'll be many more. Trial sites is the answer. And the good news is anybody who wants to trial this will save the customer £10,000 per 10 kVA IPS not fitted. And also, I think in the first place, instead of piling into a theatre, we should perhaps trial a group 2 in an ITU, or where discontinuity is the only risk, i.e. they're not penetrating the skin yet. So we can then do that because it's not diving in head first. This is dipping our toe in the water and actually not going into the highest risk rooms, but just using a low risk group 2 one. So that's that. The legal discussion. This design is obviously not listed, and I know it will make resistance because people will just say, well, there's nothing in the guidance. So it's a chicken and egg situation. Until it's trialed, it won't get in the guidance. And as you know, derogation is permitted if you do a full written risk assessment. And I started doing that. And again, from what I've said today, I think the only risk is electrically is from old devices. Okay. I realise this will take significant time to change the UK guidance because, for example, there's no system to challenge the current system or allow for radical ideas like this. Okay. And it seems the way forward is to prove it works, but to do so, it requires a prior risk assessment to prove a good duty of care has been followed. And I have produced a prior risk assessment. Any serious failings or deaths that would occur would be investigated by HSE to establish if there's a failing of this. But if you do that, then you have already carried out a duty of care, okay? And I think there's enough evidence to take this forward. So this circuit can only be commissioned if the healthcare provider undertakes a careful governance process within the electrical safety group. And it includes the clinical engineering team who need to be on board. They need to collect all medical equipment information to be used in that location and then inform the electrical safety group of all of that, like I teach and what I've explained. You'll need UPS spare capacity, which is normal anyway. And this practice should be in place anyway with it as per HTMO 601, but I know it isn't. So the electrical safety group need to include clinical staff to ensure the risks are not affected, clinical risks are not affected. And they also need to put a monitoring system in place as part of the trial so that it can be used to evidence that MTNS is a cheaper, less complex and just as safe, if not safer, wiring system than medical IT. So that's the end. That's details of what I can do with my training. I'm going to stop sharing now. Oh, hang on. Right, let's go. Right, I'm back in there. Are you there, Edith? Hello? Is anybody there? Right, is anybody?
Yes,
Okay.
you are not
Okay.
alone.
Yeah.
Thank you.
No, thank you. Right. Okay.
Thank you very much, Ian.
We've got quite a few. Thank you very much. Yeah. Right. Any questions, please?
You've given us a lot. You've given us an awful lot to think about
Have
there.
you
Yes.
going?
So,
Yeah.
folks, yes, folks online, please either turn your camera on or put up your hand, and we can come to you for questions or type questions into the chat. We're probably all still trying to absorb all of that, but it sounds like there's greater safety because it's very clear what's what as well for staff using the equipment. If you have the things with the lights and everything as you're saying, and easy to access and change, and then obviously saves money as well. So quite a lot of benefits.
Is anybody willing to, I don't know how many designers are here or estates departments that have got good relations with their estates, sorry, with their clinical engineering. I'm finding that some who were educated in the 90s are still pushing back because they've got the concept of what patient leakage current is and the protection. So, as I said before, hopefully you feel you're much educated about this all, but I'm now searching for somebody who's willing to work with me, and I'd happy to work pro bono to get this concept trialed.
That's a very impressive offer. No, someone's going to bite your arm off for that.
Right. Yeah,
Very-
sure. Cool. Yes is the answer to that. We recorded, but yes, I I feel that today is probably a lot to take in, and you probably want me to repeat it again now because I do work at a sort of a very intense level. So the thing is that it needs a lot of studying to look into this, but hopefully I've lit the blue touch paper, and I'm desperate to get people to trial this. No, nobody.
I thought it was
Anybody
interesting
got?
what you said about old medical devices as well, and the kind of, well, 10 years old. But I suppose a lot of hospitals, are you saying at this stage you wouldn't expect them to have older older equipment? You'd
I'd
hope,
hope
but
not.
yeah.
It is possible, but the point is that how things have significantly changed.
Mm,
And with the values, everything. It's
mm.
time to. This is why it's time to review. I can't repeat myself enough, but I don't know. I'm not getting questions. Please, anybody got any comments? Hopefully, it's. Uh, I don't know. I don't know how it's gone with people. They're scarily silent.
Well,
Uh,
Ian, you've given, maybe I don't know if you want to reshare the last slide, obviously, so people could just take a note of your email address, because I imagine maybe people, as you say, there's so much to absorb, they might just like to come back to you as well with the.
Yeah, I don't know what the best way to share them is. I think if I give them to CIBSE,
Yeah,
shall I give
we'll
them to
certainly
you and
put
then
them.
you?
Absolutely, thank you. We'll certainly put them on the CIBSE
Yeah,
website alongside the recording of this, which obviously
yeah.
we'll chop off the while we were in the waiting room at the start. But um, yeah. So
Okay.
you want to
Well,
Sorry,
volunteer?
sorry,
Oh
so,
yes,
sorry.
somebody's speaking.
Quick,
Great, welcome.
hello
I
there.
did.
I just got a quick question. You
Yeah,
said you're going to post them on the CIBSE website. Could you put the link in of where they are on the CIBSE website, Edith?
yeah.
Yes.
Yep,
When you put the link in where? Link.
in the chat.
Oh, in the chat. Oh, yes. Okay. I don't have that. I don't have that yet, and you'll lose access to this chat, I think, after the
Well,
meeting.
can
But
I
we can.
suggest to put it on my website? Will that help? Or
Yes, that would very much help.
I can put it on my if ever I can type it now is hang on dot medical
And we will, as I say, get them onto the CIBSE website, but I just need to find out. Obviously, it'll be under the healthcare section, but we could also send a notification when the recording is up to people who registered.
Yeah, I'll stick it on there today. If you can't find it, if for some reason I've not got the URL correct, then just go on to medicallocations.co.uk and go to final testing in the top menu, and then you'll find it there. I'll do it straight after this, then you've got it, yeah? And then I'll send it to Edith as well for the formality of more people reading it. But all I can ask is that if there's any designers out there who I think perhaps are going to do a private hospital, it doesn't have to be in the UK. It could be in the Republic of Ireland, for example. It's where there is a team where there is a good bridge between estates and clinical engineering, and you work together well. Some places, I'd say, it's like they're just across the river. I'd say a lot of places in England, it's like two planets, where they don't talk properly, and that's how it is. But yeah, you know where I am. I can give you my. Well, let's give you my email address as well. So you can hang on. Where are we? MedicalICloud.com. There you go. All right. If you email me that, then I can,
Someone
obviously.
just coming to join us.
Pardon, Edith?
No, just another person coming to join us.
Oh, yeah. Right. So yeah. Okay. Well, hopefully that was useful to everybody. I hope you've learned a lot. And thank you very much for your time, and all the best.
Thank you very much, Ian. That, as I say, yes, you've given us lots of food for thought. So I hope lots of the people who listened will be back in touch in various aspects.
Good. Okay. All the best, everybody.
Have a good afternoon, everyone. Thank you. Bye.
Can you stay on, Edith, please?
Yes, I will stay on. Yes.